Dear participants, this is Sarika Jain, and I have to announce that I have a message from one of the speakers, Kaushik Roy and Manas. One of the speakers has some emergency right now, and Manas is in stress because of the same. Both of them are not able to present the tutorial for the time being, and we are not also able to swap it with the tomorrow's tutorial because Dr. Nandana is not available right now. So we will have to sadly cancel the today's tutorial. What I have done is I have just looked on web. I have found a similar tutorial from the same speakers on YouTube. I have passed on that in the chat. The interested participants, please go through this video if you people want to hear about knowledge infused learning. Manas and Kaushik, both of them, Manas has even done his defense in the same field at University of South Carolina, United States, and Kaushik Roy is pursuing his PhD with Dr. Amit Sheth at the same institute. But right now they are not in a position to speak at this moment. Hold on. Please give me 1 minute. I have a call from Dr. Nandana who have a tutorial tomorrow. Let me check if he could deliver it right now. Please give me a minute. Hello all, there is a good news. Dr. Nandana was to deliver a tutorial tomorrow on knowledge-based question answering. So he has kindly consented and agreed to deliver the tutorial today instead of tomorrow. So that Manas and Kaushik could get a 24-hour space. And if Kaushik really feels well, then they could deliver it tomorrow, else we would have to cancel that. So Dr. Nandana is just joining us within 2 to 3 minutes. Thank you for your patience. Hello, Dr. Nandana. Welcome to the tutorial. We are again disturbing you today.
No, it's okay. I mean, I was just outside and stepped out, but now I'm back, so I can.
Okay. That is great. So I hope you are ready with it.
Yeah, I think we can move on with that.
Fine, fine. You please present your slides, and by the time you present your first slide, I will take your permission to introduce the speaker to the audience.
Okay.
Yeah, this is Dr. Nandana Mihindukulasooriy with us. He is a research scientist at MIT IBM Watson AI Lab.
I just need
Yes.
the permission to share the screen.
Okay, okay. Hold on. Yeah, please check now.
Yeah, I can do it now. Yeah.
Yeah, Dr. Nandana, his research interests include relation extraction and linking, information extraction, knowledge representation and reasoning, and also neurosymbolic AI. Dr. Nandana holds a PhD in AI and has published many peer-reviewed papers in prestigious journals, conferences on semantic web and knowledge graph related topics. So welcome, Dr. Nandana. We are happy to have you here, and over to you.
Thank you, Dr. Jain. Thank you for the introduction. So I will start. I will talk about the knowledge-based question answering in this talk. So please feel free to ask questions then and there. I might not see the chat myself. So Dr. Jain, please interrupt if there are any questions.
Yeah, I'll take care. Thank you.
Thank you. So let me move forward. So in this talk, I will talk about a little bit an overview of knowledge-based question answering. And then more specifically, I will talk about a neurosymbolic question answering pipeline that involves semantic parsing. And then also I will present some of the results that of our question answering, knowledge-based question answering work. And then I will finish with some of the future directions. So as you know, I mean, for a long time, we have been using keyword search to find information like in Google. So we ask some questions and the question is analyzed for the relevant keywords. And then we normally go to a document index and try to find documents that contain answers relevant to the given question. As you can see, this is not optimal because you need like someone manually going through all these documents and then trying to find the answers. And now, even in Google, you can see that when you ask a question like this, you will directly get answers, not the document itself, but the answers for your question. So this is in the background. What is happening is instead of like a document search, what is happening is question answering is like the Google or whatever the system behind it try to understand your question and then try to find the exact answer for your question. So this is the knowledge graphs. I mean, we have been talking about knowledge graphs in the first part of today when Pooja, Ankush, and Dr. Jain presented the application of Oligraph. So I will not go into like too much introduction into knowledge graphs, but as you can see, we used to have like documents of natural language text about entities before, but now we are moving more into graphs with facts. So we have entities in the graph, and then we have like specific facts about these entities in a graph that you can see on the right-hand side. So in the left-hand side, what you see is a Wikipedia. And then on the right-hand side, you see the same information about entity in Wikidata. So in this case, the entity is Arvind Krishna. You will see the natural language text on the left-hand side, but on the right-hand side, you can see the entity with the relevant facts for that entity. And here we can see some popular open knowledge graphs, including DBpedia, Freebase, OpenPsych, Wikidata, and Yago. As you can see, these are like reasonably large knowledge graphs that contain a lot of encyclopedic knowledge about the open domain, about the world. And then here you can also see like the size of these knowledge graphs. So knowledge graphs normally contain like some conceptual knowledge, or like we call the T-box knowledge, the term, and then we have like data or A-box knowledge as well. So in this table, you can see both the statistics about both, like the number of classes and relations tell us some idea about the T-box or the concepts and the relations of these knowledge graphs. And then if you see the number of entities, number of instances, the other information like unique subjects, unique literals, these provides an idea about the actual A-box or the data size of these knowledge graphs. So let's look at quickly an introduction, like what is knowledge graph question answering. So if you see a knowledge graph like DBpedia, you can see that it has a T-box. This is like the schema. You can think of it as the schema, which has types and classes and the relation between them. So in this case, you can see that there's a university, there's a person, and there's a relation between the person and the university, that the person has a university as the alma mater. And then you have a company, and then company and a person can have relation, a key person. And then you have a place, company and place can have this relation of headquarters, so on and so forth. You can have this schema of the knowledge graph. And then what we call A-box is the data that you populate using this T-box. So in this case, in this running example, we were using Arvind Krishna as the example. So if you start with Arvind Krishna, he has alma mater as IIT Kanpur, and then also University of Illinois. And then if we take IBM, IBM has Arvind Krishna as a key person, and then its headquarters in Armonk. So all this information is represented in the A-box in the knowledge graph. So when you ask, if you remember in the question, our initial question was, where did CEO of IBM study? So in order to find answer to such question, you can use the knowledge in such knowledge graphs. So you starting from IBM, you know who is the CEO of IBM, who is Arvind Krishna, and then you can use the alma mater relation to find where Arvind Krishna studied. So similarly, we can see the same thing in Wikidata. So the T-box is different. So it has different classes. Instead of person, it has human. Instead of place, it has city. Instead of company, it has business. Instead of university, it has educational institution. So now the schema or the ontology is different because it's Wikidata. But as you can see, conceptually, it represents the same information. And then if you look at the A-box in Wikidata, you more or less have the same information, but represented in a different ontology. So the task of the knowledge-based question answering is like, given a natural language question, like where did the CEO of IBM study at? So that is the natural language question. To convert it into a structured query, in this case using the Sparkle query language. So once you can convert this natural language query into this Sparkle query, you can run this Sparkle query against the knowledge graph and then get the correct answers, get the answers that you are looking for. So this is the generic task of knowledge-based question answering. And then as we will see in the coming slides, this will lead us to many subtasks going from the natural language question to this structured query in Sparkle. So the other thing is like, depending on each knowledge graph, the query changes. For example, if you remember a little bit about the T-box of DBpedia, it had things like key person and the person class and the alma mater relation. So when you create a query for DBpedia, you need to use the schema of DBpedia in order to create this query. And if you look at in Wikidata, it has a different schema, and you will be using a different set of relations and classes in order to create the query in Wikidata. At the end, you will, the idea is like starting from some entities like IBM, you should be able to get into the place where the CEO of IBM study using such query. So now we come to the evaluation. So one important thing in any research area is like how we can get things evaluated. So for KBQA, we have like a lot of benchmark data sets that we can use to evaluate KBQA systems. And then you have this system Gabriel, which is an evaluation platform that you can use to evaluate question answering systems. So normally these evaluations happens is like a set of test questions, and then you have the gold answers. What is the correct answer? And then you get the system answers as well. So you pass these questions through a system, you get the system answers, and then you can compare the system answers against the gold answers to calculate the precision, recall, and F1. For example, in this case, this is like an illustrative example. So in this case, if we ask the question of where did the CEO of IBM study, the gold answers, there are like 4 gold answers, like University of Illinois, IIT Kanpur, and then Staines Angelo Indian School, St. Joseph's Academy. So these are the gold answers. If a system can come up with these 3 answers, University of Illinois, IIT Kanpur, and MIT. So in this case, 2 answers are correct, 1 is wrong. So the precision is 2 out of 3. And the recall is 2 out of 4. So, and then based on that, we can calculate the F1. So this is how normally the question answering systems are evaluated. And these are like some examples of benchmark data sets that are available for evaluating KBQA systems. As you can see, there are like different target knowledge graphs. So in some cases, it's DBpedia. In some cases, it's Wikidata. For example, if you see the QALD LC code, it's DBpedia. And then LC code 2, it's Wikidata. And then there are like set of benchmarks on Freebase as well. So if you are building a question answering system, you can use these benchmarks to evaluate your performance. And then also there are like domain specific benchmarks as well. Maybe Dr. Jain in the discussion will talk a little bit about the legal domain. There are like benchmarks that especially from the semantic intelligence team that are proposing on a legal domain, and there are like other benchmarks for specific domains as well. And similarly, here we are looking at a little bit more detail into the KBQA data sets. So one thing is the knowledge base. The other thing is like, what is the emphasis? We will talk a little bit about like the different complexities in knowledge-based question answering. One is like multi-hop questions. So it's like when trying to find an answer, you need to traverse the graph like several hops. An example for that was the same question that we were looking at. Where did the CEO of IBM study at? So we are not really mentioning Arvind Krishna in the question itself. So if you need to answer this question, first you need to find who is the CEO of IBM, and then try to find where he studied. So these kind of questions where you need to traverse several hops to find the answer, we call them multi-hop. So this is like a important aspect in knowledge-based question answering. And another emphasis here mentioned temporal questions. So some questions are trying to understand the temporal nature of questions. We will see some examples in the coming slides. And then you also have like templated question and natural questions, because sometimes when you want to create a large data set, you don't have enough, it's very hard to do it manually. So something that you normally do is like you create a template and fill them with some entities. So that way you can create a large data set without too much manual effort. So in the but the problem is the templated questions are not as good as natural questions. So here in the last column, you can see if the data set contains more natural questions or templated questions. And now we will look at like common question types in KBQA. So as you can see that now we talked about multi-hop questions. Let's look at like different types of questions in KBQA. As you can see, the easiest or like the most simplest ones are the simple questions, where the question is straightforward. So for example, a question like, who is the mayor of Paris, which is a straightforward question to answer. We call them simple questions. And then there's another type we call taxonomic reasoning. So which ask, for example, who are the actors born in Boston? So you need to understand that someone is a actor and that he or she was born in Boston. So these kind of questions, we call them questions with taxonomic reason. And then multi-relational, which are similar, which is another way of saying multi-hop questions that we discussed already. And then we have count questions. For example, a question like, how many theories did Albert Einstein come up with? So this is like, you need to find out all the theories that Albert Einstein come up with and count them. So these kind of questions, we call them count questions. And then we also have something like superlative questions. So superlative question is like you compare the answers with different other answers. For example, which is the second highest mountain in Italy? So you need to find all the mountains in Italy and order them, and then find what is the second highest mountain. So these kind of questions, we call them superlative questions. Similarly, we have comparative questions. For example, a question like, does Breaking Bad has more episodes than Game of Thrones? So to answer a question like this, you need to find first how many episodes does Breaking Bad has, and then how many episodes does Game of Thrones has, and then compare them in order to find the answer to a question like this. So these kind of questions, we call them comparative questions. And then there's some other questions that need geographical reasoning. For example, was Natalie Portman born in United States? So in order to answer this kind of question, you need some geographic reasoning. So because normally you will have the city a person born in the knowledge graph. So for example, it will say Natalie Portman was born in New York, or Natalie Portman was born in London. So in order to answer these kind of questions, you need to first go to the city that the person was born, and try to see if that city belongs to United States or not. So these kind of questions, we call them geographical reasoning. And similarly, the last one, we have some questions that need temporal reasoning. So one such question is, who were the presidents of United States when Joe Biden was a teenager? So to understand a question like this, so you need to first understand when Joe Biden was born. So if you know when Joe Biden was born, you can understand which years, which is the time span he was a teenager. And then you need to find out who were the US presidents during that time span. So these are like different types of complexities in knowledge-based question answering. And some systems handle all these complexities, while some systems handle some of them.
Dr. Nandana, before moving forward, there is a question from Dr. Valentina. Will you like to unmute yourself?
Yes, my question is about these data sets. Are all data sets in English language?
So the ones that I have shown here, they are all actually in English language, except for LC code 9, the one in the top, I think, which has like 9 languages. So it has Spanish, German, even Hindi, I think. So it was translated into 9 languages. But there are several other data sets which I have not included here, which has multiple languages. Okay. Are you looking into specific language or?
No. I'm just interested about how the science is going on in this. For example, are there any data sets for Arabic, for example? Because we have explored a little bit the Arabic language and the Arabic DBpedia, so that is why I have asked this. And also another question is, for example, you have all these complexities analyzed for the questions. So these types of questions. Do you have a feedback for example, how the DBpedia schema should evolve in order to better or easier answer the questions?
That's a good question. So let me start with the Arabic one. So I think there are, now I don't recall exactly which data set, but I recall seeing Arabic questions in some of the KBQA data sets. I know the other interesting thing is, like, even if we change the natural language question, the Sparkle query is exactly the same, right? So converting any of these benchmarks into Arabic only require changing the question into Arabic. So I think QL, I'm not completely sure if QLD9 had Arabic, but there, I remember at least there was one data set with Arabic questions. So it will be interesting also if there's enough interest to take one of these benchmarks and translate the questions into Arabic, and everything else, like the evaluation, the gold standard queries, everything will remain the same, but the questions will be in Arabic. So it will be also something very interesting. Regarding the complexities of the question types and the schema of the knowledge base, it's also a very interesting question. So depending on the schema, some of these questions become easier or harder. For example, the Wikidata schema represents temporal knowledge in a very quite flexible way using statements. So you can say that Joe Biden was president of United States, and then you can add the start time and end time. So when the schema of the knowledge graph is quite flexible and well thought, it becomes easier to answer some of these questions. But for example, in DBpedia, when we say Joe Biden is president of United States, there's no like easier way to put the start and end date. So in such cases, answering temporal questions, for example, in this case, becomes harder. So yes, so I think the knowledge-based schemas has to be designed in thinking about these different types of question types. And Wikidata, for example, we see that the schema is much more flexible for answering all these question types compared to DBpedia. But I think DBpedia and all the other knowledge graphs also will make their schema evolve with the experience and with the lessons learned from question KBQA question answering. Does that answer your question, Valentina?
Yes, I think that, I mean, I have worked shortly with the group that is maintaining the DBpedia, and that is why I have initiated this question. But it will be really good to have that feedback, you know. Maybe, but we don't, on our side, for example, our institute, we don't have these people that can do that. But maybe you can contact the DBpedia community and somehow share the experience and maybe suggestions, or maybe in one of the events that are going this year or next year. So just to point to that, you know, because this is very important. Important topic in order to advance with a lot of applications in different domains.
Yeah, I agree. I think it's a very important point. I think it has been already raised in some of the events in DBpedia as well. So it's not quite straightforward thing to change the schema in DBpedia, because the whole pipeline kind of depends on the schema. But I think gradually it will start making these changes to make it more suitable for these kind of different types of reasoning.
Yes, thank you very much for the answers.
I also have to add here, as you just mentioned, yes, it is difficult to change the schema of DBpedia at this point of time. But as we mentioned in the morning, for the domain specific applications, for the domain specific schema that we are just creating even, I hope this should be one of the points to consider while creating the schema.
Yeah,
yes,
totally.
I agree. Yes, because for example, we are now working in some domain applications for an electricity domain or for energy domain. So it is very important to look at top down. So we are starting that way, yes, to analyze the business questions first.
Yeah. Okay, thank you.
Okay.
I have a small question, if you allow.
Please go ahead.
Yeah, sir, there was one slide where you mentioned the tool for evaluation. So can you just switch on that? Yeah, this tool. So what does that tool does in the background? Does it have any specific questions where you have to feed the answers, or how the evaluation takes place?
So it has like several levels. So in the easiest level, so it has like these benchmarks, and then you kind of input the gold standard and system standards system answers for the system, and then it will provide you all the evaluation metrics. So this is only for a single question, but then when you have a benchmark with like 1,000 questions, you just put tell that I'm evaluating QALD, and these are my system answers. It will go through the system answers and compare it with goal answers, and then compare these metrics. And then this is only for the single questions, right? But then when you have like 1,000 questions, there's like other complications, like this micro F1, macro F1. So all these different definitions of metrics, it will go through these metrics and generate these metrics. So the advantage you will have is like then the numbers you get are directly compared with the previous work. So you just generate your system answers like this to all the questions in the benchmark, and then provide it to this system, and it will generate all the metrics that you will need to compare your system with all the previous work.
Okay, okay. So this is just for the question answering system.
So this, the one that I'm showing right now, there is a Gerbil QA. It's only for question answering, but I think they have like other systems for entity linking, and so this is like a one of a bigger umbrella. And in the bigger umbrella, they have like other things as well, like name entity recognition, entity linking, and there are like they have benchmarks for several other tasks as well.
Okay, thank you, sir.
So let me go. Are there any other questions?
We could move forward now.
So I will quickly go through like some of the different types of systems. So in the past, and even in more recent years, like for example, this is in 2020. So one of the ways to do this is through rule-based systems. So what you normally in a rule-based systems, you have like smaller NLP task. Given the question, you can do like part of speech tagging, tokenization, and then what you call this n-gram tilling, that you kind of try to merge different tokens and try to understand the name entities. So you can do these smaller themes, and then you can have like several rules in order to put them more like triples. So you are basically converting the natural language question into a set of triple patterns. And then once you create these patterns, you can try to come up with the Sparkle query based on these patterns. So this is like a one of the earliest ways of solving question answering, and still popular rule-based approaches. And then also you can think of question answering as a translation, right? So on one hand, you will have the natural language questions in English or in any other language. And then the other side, you will have the Sparkle queries. So you can think of this task as a machine translation task. So the task is given a natural language question. Can I translate it into a Sparkle query? So there has been a line of work that works on that direction. So translating the natural language questions into Sparkle or more structured query languages, starting from 2014, for example, from this work. And then, so this was like a more like earlier version of it. And then you can do the same thing using these current neural approaches. So things like LSTMs and sequence-to-sequence the kind of work. So the idea is you feed the natural language question on one side and then train a model that can generate the Sparkle queries token by token using a set of training data. So that's some what you see in this example. And more recently, we are following the same approach. It's like getting quite popular using sequence-to-sequence models. So which normally does read some set of tokens on one side and then create a set of tokens on another language or another formalization on the other side. So as you can see here, the task is like you feed the question to the model from one side, and then the model is expected to generate Sparkle queries as its final output. So these kind of models can be trained using a set of natural language queries and Sparkle queries as training data. And the task of the model is to generate, given a natural language question, the Sparkle queries. And then in recent years, we have like a lot of advancements in these kind of machine translation based approaches using sequence to sequence models. So one of the latest models is this BART model, which is a sequence model that has been trained to do many tasks. So one of these tasks is converting the natural language questions into Sparkle queries. Also, there are like another line of research, which is called case-based reasoning. So here the idea is, given a question, you kind of can cluster the questions into similar questions, and then you try to find examples that are similar and group them together. That way you can understand for a given type of question how to generate the query. So in that way, by clustering similar questions and trying to find patterns of answering them, you can generate systems that kind of learn to generalize a question and then use the previous examples it has seen in order to generate the Sparkle queries for the new questions. And then another recent line of work is what we call this neuro-symbolic question answering. So here the idea is to merge both the neural approaches as well as symbolic approaches together, and then try to get the benefit of both of these worlds in order to build a better question answering system. So this is one example of a question answering system that we built following this neuro-symbolic paradigm. So here, given a question, what we first do is like pass it using semantic parsing. So this is for that we use something called AMR, which is called abstract meaning representation. So if you can see in the bottom, the question is, which actors starred in Spanish movies produced by Benicio del Toro? So that is converted to a graph like this using abstract meaning representation, semantic parsing. And then we do entity linking on top of this graph. So basically in this graph, we try to find what are the entities. In this case, we identify that Spain is an entity, Benicio del Toro is an entity. So we link them to the knowledge base entities. And then we perform something we call path-based graph transformation. That is like we kind of try to align this AMR graph, which is a semantic representation of the sentence, abstract representation of the sentence, into the knowledge graph using these linked entities. And then using that, we kind of try to understand the relations in the knowledge graph that matters to this question. For example, in this case, because we were able to link the Spain and Benicio del Toro into the knowledge graph, we can understand that DBO country, DBO producer, starring, these are the relations that are relevant relations in the knowledge graph for this query. And once we do that, we can use some sort of reasoning we call logical neural networks to come up with a query like this. So I will not go into too much into details about the each of the individual components, but the overall idea is like as you can see, I will show a little bit. So at this level, it looks a lot more symbolic. So all these things are more like symbolic way of answering a question. And then at individual levels, like at the entity linking, relation linking, and also like when we generate the Sparkle query, we use the neural models in this smaller subtasks. So let me quickly go to, so as you can see, the entity linking task is like to understand the entities in the question and then try to link them to the entities in the knowledge graph. So in this case of who is starring in Spanish movies produced by Benicio del Toro, we can understand that Spanish in this case referred to the Spain country, and then movies is referring to the type DB of film, and then Benicio del Toro is referring to the entity Benicio del Toro in the knowledge graph. Similarly, if there's a question like who composed soundtrack of Cameron's Titanic, we need to disambiguate and understand that Titanic in this case is referring to the film Titanic, not the ship Titanic. So that is one of the complexities in entity linking. You need to disambiguate and understand, because there are like multiple entities with the same or very similar labels. In this case, Titanic, the film is also Titanic, the ship is also called Titanic. So we kind of need to disambiguate and understand which entity the question is referring to, and then link them correctly. And also similar, the same with Cameron. So there might be many Camerons, people with the name Cameron in the knowledge base. We need to understand and link it to the correct person. So this thing involves two main steps: the name entity detection. So understanding this span of text is an entity, and then linking it to the correct knowledge graph. So this is the entity linking subtask, which is kind of a essential step in knowledge graph question answering. So I will not go into details of the approach, but let me quickly go to the relation linking task as well. So in the relation linking task, the task is like given a question like who is starring in Spanish movies produced by Benicio del Toro, to understand which relations are relevant to answer this question. So in this case, the most relevant relations are DBO producer, the executive producer, manufacturer. So these kind of relations are the ones that are relevant to answering this question. So the task of relation linking is to understand these relations and link them appropriately. So let me quickly go through them, these as well. And so these are like the modern relation linking models. Earlier, we used to have things that were more rule-based, and now we are moving towards to more neural models. So because based on the time, so let me quickly go to the final conclusions right now. So let me look at the challenges and then take a few questions to end the talk. So the main challenges right now is like, as we as we discussed before, there are many complex ways of complex question types. So understanding these complex question types and generalizing them is still a challenge. And then also for the neural approaches, finding large-scale training data is still an issue, especially for domain-specific question answering. For example, we are looking at legal question answering, and we see that it's not easy to find large-scale training data for such data sets. And then also for neural approaches, handling the robustness and explainability is still quite a challenge. So with that, I think let me see if there are any questions.
Hello. Yes, sir.
Yes, please go ahead.
Yeah. Very useful talk, sir. And my question is, what are the suggested tools to link the relations with the knowledge graph?
Okay, so there are like multiple approaches in the literature. If you look at that, like some of them are like open source and available as well. In the most recent literature, what people are using is like what we call generative like sequence to sequence models. So basically you can given if you have like labeled training data, you can train a model given the question to generate specifically the set of relations in that question. I would recommend you to look at like, for example, this paper that I showed before. So this paper, generative relation linking for question answering over knowledge bases, it was last year's ISWC. This actually shows the approach for doing generative relation linking, and also has several links to other work, relevant work.
Okay, sir. Thank you. And one more question is how we classify the NLP questions. Is the question is simple or taxonomy or a comparative questions? How we classify? Yes, sir.
Yeah, I mean, that's one of the approaches. So to understand them and classify them. So you can actually train a classifier based on language models to understand whether it's like whether it's a temporal question, whether it's a geographical reasoning, all those things. But the most common approach right now is like to without classifying, just try to build systems that can handle most of these question types, rather than trying to first understand the type and answer question, but to build more generic systems that can handle multiple question types.
Okay, sir. Thank you.
Are there any other questions?
Are there any questions in the audience? The participants could unmute, please. It was a very nice talk indeed, Dr. Nandana. I also want to ask you one thing. What is your opinion on domain-specific relation and entity linking? Because we could locate very less models or approaches available.
Yeah, but I think this is still an area that actually a lot of work has to be done. So most of these entity linking, relation linking are focused on open domain generic areas, and adopting them to like specific domains like legal or finance, I think still needs a lot of work. And I think that's an area people should put more focus now.
In that manner, what I feel is the models that will generate, that will come upon, will be domain specific themselves.
Yeah, I think what would be like a reasonable approach is like start with the models that are trained on like open domain, because there's large number of training data and large number of data available for them, and then kind of fine tune or like make them more kind of adapt them into the domain specific ones, right? So I think that's something that people from biomedical also has done for some time. So they start with something that is kind of trained for open domain, but then specialize it and fine tune it more into the biomedical domain. So I think the same similar approach can be followed by other domains as well.
Yes, you are right. Okay, I hope the participants have really gained a lot from this talk, and it is an emerging area, and someday or the other, the machine translation should embed this background knowledge into it. The symbolic approaches also, as you just mentioned, previously we were doing question answering with the rule-based approaches, but now the symbolic approaches are moving towards the machine translation. So it was a good learning. Thank you, Dr. Nandana. Thank you very much. You spared a full day today, I suppose, in tutorial 1 as well, and this tutorial as well, because there was an emergency with the other speakers.
Yeah, it was a pleasure actually. Yeah, it was
thank you so
very well
much.
organized event. Thank you so much for the invitation.
And thanks to the participants as well. So we will join again tomorrow, same time, for the third tutorial. of the conference at 10 a.m. CEST. By then, bye-bye to all.
Thank you very much. Bye.
Bye-bye.